All right, we're going to do the prime checker program. We have to use start and end and find a report for each number from start all the way up to end, whether it's prime or not. And I give you a big description of how to do that here. And I expect you to read that. Now I'm just going to go ahead and do it. So for int, I'm going to say num in range, int num equals start, num less than end plus 1, or less than or equal to end, and num plus plus. That way, I'm working with num. Num is the number I'm checking. And then inside here, I'm going to make a count variable equals 0, and then I'm going to do a for loop. Int I equals 1, I less than num, I plus plus, and that's going to go from 1 up to 1 less than the number. And we're going to check if num modulo I equals 0, then we have found a factor, count plus plus. So we go through all those numbers, we check if it's a factor, and if it is, we add 1. And now right here, we can tell if it's prime or not. We can say if count greater than 1, equal to 1, system.out.println num is prime, else num is composite. Let's run it, see how it works, if it works. There you go. That's all I was asking for. You should take this apart in your mind, or, figure out what's going on here. I mean, one thing you could do if it's not making sense to you is you could print out system.out.print num plus a space. And then every time you find a factor, you could, in addition to counting, you could system.out.print I plus a space. And then after the whole loop, before you say the number's prime, you better print a blank line. Check this out. This will show you that the factors of 6 are 1, 2, and 3. So here's 6, 1, 2, 3. Those are all the factors. I mean, including 6. That makes it a composite number, but 7 just has 7 and 1. 8 has 1, 2, 4, and 8, so it's composite, and so on. That's obviously just so you can understand what we're doing here, and I hope that helps a little bit. Let me know if you have questions.